Hi everyone, this is the first talk of our symposium on the role of the body in science education. My name is Magdalena Kersting. This is joint work with Jesper Ackland and Rolf Steyer, and I suggest we get started right away. So the overarching question of our symposium, but also of this talk specifically, is, well, what is the role of the body in science education? And as you will see shortly, there is no one best way to think about the body in science education. And what we usually view as a quite simple notion, our body, it's pretty obvious that we have or that we are bodies, well, opens to a multitude of theoretical perspectives that build on different traditions and premises about science learning. And in my talk today, I want to shed a little bit of light on these different traditions and premises. So I think two examples can illustrate the crucial relationship between the body and physical movement on one hand and conceptual learning in science on the other hand. And if we think of learning physics and classical mechanics, researchers found that gestures can provide sensory motor information that prompt idea construction. So to make sense of these quite tangible concepts, we use our hands and our bodies to understand them better. On the other hand, I mean, classical mechanics is quite tangible to begin with, but on the other hand, many domains in science are just or belong to some of the most abstract areas of human thought. And in these abstract areas, to make sense of these abstract concepts, we use our bodies differently, namely in the form of projections or the transfer of sensory motor experience onto my abstract domain. So we use the information and experience that we gain from or through our bodies and project them onto these abstract domains to structure abstractions. And our everyday language often reflects these projections in the form of conceptual metaphors. And I think these two examples, using gestures to make sense of physical phenomena, but also using conceptual metaphors to make sense of more abstract concepts, they first of all illustrate that there is an important link between physical movement and our body and conceptual learning on the other hand, but also that there's not just one way that the body bears on science education, research and practice, because these examples clearly concern different mechanisms. And this was really the starting point for our work, realizing that science educators and science education researchers, they use concepts of embodiment and embodied cognition interchangeably, although there are important differences and nuances. And our goal was to disentangle the different aspects of embodiment and trying to make sense of them and really trying to bring clarity into the different approaches and traditions towards embodiment in science education. And in order to do so, we turned to philosophy and psychology, and clearly 10 or 15 minutes are not enough to do justice to these traditions. And if you are curious to learn more, I can only invite you to take a look at our paper, because in our paper we have enough time and space to really elaborate on these different traditions. So here I just have to go through them quite briefly. So we start with philosophy and phenomenology, and I think I'll just make myself invisible so that I'm not in the way. Here you can see Maurice Merleau-Ponty, and he was really one of the first philosophers to stress the embodied context of human experience explicitly. And within our Western tradition, phenomenology is by and large the philosophy of human experience. And Merleau-Ponty acknowledged that our bodies are the mediators of our reality. So for Merleau-Ponty, embodiment has this inherent double sense. It encompasses the physical body as the context of cognitive mechanisms on one side, and the phenomenological body as a lived experiential structure. And we were very much inspired by his perspective of viewing embodiment through a double sense. And this is why we introduced different senses of embodiment to understand the role of the body in science education. But of course, Merleau-Ponty was not the only one pondering these questions. And if we turn to psychology, here you can see James J. Gibson. And he is one of the founding fathers of ecological psychology. And for Gibson, cognition is not restricted to our brain, but it is really an expression of our bodily agency in the world. So we can say that cognition emerges in and through the actions of an organism in its environment. So we can really say that the embodied nature of cognition stems from an understanding of cognition as being for a body's action. And this is quite different to the usual separation between the organism and environment that we used to see in psychology before Gibson. And then when studying phenomenology and ecological psychology, it became quite clear that the main focus in these theories of embodied cognition had been on the relation between the individual body and its cognitive processes in interaction with the material environment. However, for us humans, having a body and being a body and interacting with our world, well, this world also comprises the social and the cultural context. So a natural starting point to approach the role of embodiment in social interaction, which is also really important, is Vygotsky's theory of cognitive development. And for Vygotsky, cognition is the consequence of the intertwining of sociocultural and biological factors, and we can say that actions have social meaning and that agency takes place within a web of cultural structures. So, probably here I am again. So, this was my brief summary of the different traditions that informed or inspired our way of thinking about embodiment in science education, namely by introducing 4 senses of embodiment to characterize different perspectives of embodied cognition. And I'm going through these 4 senses. And again, this is really brief. Take a look at our paper, but I can tell you that we have tried to really show the importance of these different senses, both for science education research, but also for instructional practices. So we have tried to show the relevance by giving examples that both illustrate the research and practitioner perspectives. And again, I don't have too much time to go into detail here, but we have thought about it quite carefully. So let's start with the physical sense of embodiment, which describes embodiment as the basis and extension of cognitive structures. This sense is clearly inspired by Merleau-Ponty. And the basic idea here is that the body is a physical and a biological structure, and the relevance in science and science education is that our brains use sensory motor regions to make sense of abstract concepts. And wait, I'm just turning invisible again. And one analytical example in science education would be conceptual metaphor theory that really examines the transfer of inferential structures from image schemas to abstract domains. The phenomenological sense describes embodiment as lived experience. Again, this is very much inspired by Merleau-Ponty. And in this sense, we acknowledge that the body is not a mere physical structure, but it is also a lived experiential structure and part of our lived world, or part of the lived world of our experiences. And yeah, the idea body is a lived experiential structure. I think I've said this already. And I think what makes the sense so relevant in science education is that students need to experience science with and through their lived bodies. They cannot step out of their lived bodies, and instead of being mere observers of reality, scientists and science students are very much involved in the perception and production of physical phenomena through their bodily experiences. And I think in the next talk we are going to hear a lot more about this particular sense or this particular perspective. So I'm just continuing and going to the next sense, the ecological sense, which is of course inspired by ecological psychology and Gibson. And this sense describes embodiment as the relational codependence between a body, mind and world. And here we have the key idea that the brain is not the only cognitive resource we have available to think or to solve problems, and that the brain is not really, or that the brain does not really bound the mind. So the mind and cognition can extend into the world. And this allows us to reframe science learning in terms of affordances and really reconceptualize science learning in terms of affordances. So this new vocabulary brings processes of student environment interactions into sharper focus, and we can think about how students can offload information to reduce cognitive workload, for example. The last sense is, or our fourth sense, is the interactionist sense that describes embodiment as sociocultural interaction in line with Vygotsky. And here we just really put emphasis on the coordinated interactions with other bodies and other people. And much learning in science, just as much activity in science, is not an individual activity, but collaborative, communicative, and socially situated. And this sense considers situations that occur when people are coordinating and interacting with each other. And importantly, we want to create opportunities for group cognition, if we want to call it like that, to occur, which means that thinking and problem solving and decision making develop in the interaction between individual students. So in summary, we started out realizing that embodied cognition and embodiment, that these two notions are really broad and vague, and it's hard to make sense of them if we don't specify them better. And this is why we have introduced the four senses of embodiment that illustrate the body's many roles in science education. And this is the physical, the phenomenological, the ecological, and the interactionist sense of embodiment. And now you might think, well, so what? What is the relevance of this? Well, we have seen that embodiment really refers to a lot of different activities in learning science, as diverse as language use and sensory experiences and situated tool use and social interactions. So there's a lot going on, and we must recognize that these are very different kinds of activities, and just referring to each of them under the broader umbrella notion of embodiment loses quite a bit of nuance. And we hope that the four senses of embodiment can help us explicate the usefulness and the potential integration of these different perspectives. And importantly, the different senses of embodiment are not mutually exclusive. So we don't want to argue that one sense is better than the other, but it is crucial to recognize that there can be overlap between the different senses, and that any particular science education activity can really touch on multiple senses. That being said, I think to just finish this presentation, think about those two questions. How can students do their thinking and learning in embodied ways? And how can researchers use these insights to understand science learning in new ways? And I think, we hope to establish the four senses of embodiment as guiding practices, principles that can help us answer these questions. And I hope I'm not over time already. So if you have questions, get in touch with us. We have the opportunity to discuss, and check out our paper on the four different senses of embodiment, or just drop me a line. I'm always happy to discuss these ideas. Thank you.